Welcome to React Basics. In this course, you'll be introduced to the basics of working with React. During this module, you'll learn how to develop a working familiarity with the basic structure and use of the React.js library. Explore the concept and practical use of state and state management, and discover how to set up navigation and make use of assets in your React apps. You'll begin by learning how to work with React to build modern user interfaces, or UIs, on website front ends. This involves the concept of standalone parts of the user interface, or UI. These standalone bits of UI are commonly referred to as components. You'll explore components in more detail later in this module. For now, it's enough for you to know that every website's UI is built on a foundation of components and composability. Simple components combine into more complex ones, which eventually merge to form a website. So, a website can essentially be viewed as a highly complex component. Components and website UIs are not limited to React, but a part of the reason why React is so popular is because it streamlines the process of building and composing components. React does this efficiently and without a significant impact on your browser's resources. Another major topic that will be discussed in this course is working with state in React apps. You'll learn a lot more about state as you go through the course, but for now, here's a simple definition of state. State is simply all the values of all the variables your app is working with at any given point in time. As you progress through this course, you'll also learn about how to style your React apps, which includes the reuse of common styles, setting up your apps to respond to events such as clicks and user-submitted data, creating navigation routes and using assets. And you'll finish off the course with a portfolio project where you'll apply your new knowledge. I hope you're as excited as I am to begin this course on React Basics. Let's get started.
My team uses React, and we use a lot of new and experimental features that the React team is building. Facebook.com is like a demonstration of all the new and cool features that React engineers are working on. So when we rewrote the website, we were actually using a lot of unreleased features and kind of experimenting with a lot of new things that the React team was building, which was really cool to kind of use it first. My name is Katie, and I'm a software engineer on the React Apps team at Meta, and we work on building a variety of new features for Facebook.com. There are plenty of React-based apps that you've probably used before. Facebook and Instagram are two examples, but Netflix, Airbnb, New York Times, and a variety of other companies also use React for their websites as well, so you've likely encountered it before. These websites that tend to have really interactive UIs are more likely to be using something like React. So Facebook.com had become really not performant and not modern looking after the 10 or so years that we had been using it. We had squeezed all of the performance wins that we could out of Facebook.com. So really the only option at that point was to rewrite it on a different stack that was going to be a lot faster and a lot easier to build on. Basically, there was a need for having a really fast and responsive UI, and React fills all of those needs. So this was kind of a shift in thinking differently about how we build on web. We actually rewrote our website a couple years ago to be completely React. And so every engineer who's writing for Facebook.com at Meta is pretty much using React. I was there for the middle of it to finally launching it. So it was cool that a little bit of it was already written and we were getting prepared to show it to real users. I think 40 engineers on our team were all working on building out this MVP of the redesigned Facebook.com. And we would work with a variety of product teams to get them to also rewrite their product on our new stack as well. It was a really big effort, and it was also a really big risk. not all the teams that we talked to thought that we could ship this new version of Facebook.com. So we really had to prove that it was faster. It obviously looked more modern, but we had to prove that it would really help these product teams deliver the best version of their product that they could on web. So React is open source, meaning that anyone can contribute to it. And those engineers are working full-time on React. But we also have developers who aren't at Meta who are also contributing to React. And that means that there's a really strong community around React. And a lot of people are really excited to build on it and make improvements to it. So if you ever have any questions or you have an idea about a certain feature or optimization or improvement, there's really like a great opportunity to actually contribute to the React library itself. So there's a React team at Meta, and this team is comprised of engineers who are working on React full time. But there's also a group of developers outside of Meta who are contributing to React as well. I think the open source part of it is really cool just because there's such a community around React. It's constantly being updated and maintained, and there's always going to be someone available to like answer questions or to update documentation. It's very current. If you're using React for the first time, definitely take a look at our documentation. There are a lot of conversations being had about React online, and we actually have a React conference every year where we talk about new features with React, and you can just connect with a lot of React developers. So there are plenty of opportunities to get involved in the React community, and I think it makes building with React even more rewarding if you kind of connect with the community as well. React is used everywhere in the tech world, and you'll have the chance to use it throughout your career, so it's a very valuable skill set to have. Yeah. My name is Katie, and I'm a software engineer on the React Apps team at Meta, and we work on building new features using React for Facebook.com. My first encounter with React was actually in a senior design project back at college. We were looking for a great client-side library to use for an app that we were building, and React seemed like the easiest to use and the fastest to build on. I had already gotten my job at Meta, but I didn't know what I was going to be working on at Meta, so it was cool to kind of get this experience with React. Realized I really enjoy working with it and then get to do it in my day-to-day work. So I feel like in school you tend to do a lot of object-oriented programming, which uses inheritance. React doesn't use any of that. It uses something called composition. So that was a little bit difficult to think about, but there's so much documentation around React and such a strong community that it's easy to pick up, and you have support coming from so many different places. You can just go onto YouTube and watch a video, read through the documentation, or look at other open source projects that use React. So there's so many resources to pull from. I think developers outside of Meta choose to use React for the same reasons that we do at Meta. It's super easy to learn and pick up. You're able to create really custom UIs with React. We're building so many different features on Facebook.com every day that require a lot of custom components and UIs, so it's nice to have the flexibility that React provides. I would say React is the best choice for an app if your UI is really custom and you're looking for a lot of flexibility with what other libraries you can integrate for your app or website. React is just a front-end library. You're going to need to interact with other third-party libraries too. And if you want the flexibility of integrating with Redux or other third-party libraries, React is the perfect choice for you. React is also great if you have complex UIs where you want to reuse code across many different pages. So I think it's a great choice if you're building a complex website with a ton of features across a ton of different pages. I think React solves the problem of code reusability really well. Here at Meta, we have a core set of UI components that we're actually able to reuse across the site. And this means that we're able to build a lot of functionality into these core UI components, like accessibility. I think we're able to have a high quality bar across the site just because we're reusing components everywhere and we're able to kind of share code even across Facebook and Instagram and Messenger. So I think that's a really unique part of React. It's really interesting because if I find a bug in a core UI component and I fix it, I'm not only fixing it for my one use case, I'm fixing it for use cases across the site. So I think it's a really smart way to use engineering effort. You're fixing a bug once and you're solving one problem everywhere. So I would say the biggest competitor of React is Angular. Angular is a bit different from React in that it's a full-fledged solution for an app or website. You don't really need to integrate with third-party libraries when using Angular, whereas with React, it's just a client-side library. So you do need to figure out how you're going to do routing and server-client communication. I would say React provides more flexibility with creating these complex custom UIs, whereas Angular makes it easier to create a single-page web application with an out-of-the-box solution. Learn by doing. Try to make an example app. Don't go and try to create the most complex app you've ever heard of. I would say start simple. Make sure you're using best practices. Continuously reference documentation to see if you're using hooks the way you're supposed to and that sort of thing. And it should come pretty easily. I think one of the great benefits of React is how easy it is to pick up and learn. There are a lot of different pieces of React and a lot of different concepts to learn, but it's really well worth it in the end because you're going to encounter React in your day-to-day work, hopefully for the rest of your career. And there's a huge community behind you ready to help and answer questions about React too.
Recall the concept of the single-page application, or SPA for short. This is a one-page website where some of the page's content changes based on user interaction. SPAs differ from traditional websites, where each web page needs to be loaded as the user navigates around the site. This frequent reload can be considered inefficient, as some of the same content such as logos, navigation, and footers need to be loaded again. And one of the most popular ways to build an SPA is with the React library from Meta. React is used to run many of the world's most popular websites. Often on these sites, you'll type a search term into the site's input box. The site then returns the relevant content or results. But you might notice that even though the content has updated, the site's URL doesn't change. As SPAs only load the content as required, they can be ideal for businesses and enterprises who need a web app that offers rich user interfaces, speed, scalability, and flexibility. As an aspiring developer, you may feel like there are a lot of new concepts and processes to understand when working with React, but you can be sure that you will have an opportunity to get familiar with and use them. In this video, you will learn about the basics of React by exploring the concepts of the component-based architecture, components, and the virtual DOM. Let's begin with components, one of the core building blocks of React. When Meta released the React library, it included the concept of something called component-based architecture. This is essentially a design philosophy for building software based on reusable components of code. Each component consists of well-defined functionality that can be inserted into an application without requiring modification of other components. Because components are reusable, they can be used multiple times and easily inserted anywhere when needed. This results in components that can exist within the same space, yet interact independently from each other. One of the advantages of developing using components is that many developers can work on the same project without interfering with the code of other developers' components. As you may recall, modern front-end web development revolves around the concept of creating standalone parts of the user interface, or UI for short. Well, in React, these standalone parts are created using components, which form the foundation of all UI design. It's important to know that all UI is composed of simple components that can be combined into more complex components. In fact, you can think of an entire website as just a collection of components. For example, consider the product checkout page of an e-commerce web application. The page consists of 3 sections: a header, a payment section, and a sidebar. The header section contains the company logo with a navigation menu and a button to view the shopping cart. The payment section area contains a form where the user inputs their payment information. Finally, there's a sidebar with the order summary information. As the components are self-contained, they have their own HTML, CSS, and JavaScript logic for functionality. For example, the payment section component has a JavaScript function that submits a payment when a button is clicked. It's important to know that the use of components in website UI design is not limited to just React. Many websites' front end or UI are built on the foundations of components and composability. But React is a powerful tool for streamlining the process of building components and composing them. It performs these actions efficiently as components are rendered to the DOM without significantly impacting the browser's resources. This is called component rendering, and you'll learn more about this and its associated render method later. You may recall that the DOM is a logical tree-like structure representing the HTML document, and it uses nodes to describe the various parts of the document. Before React, you could still build component-style layouts. However, it involved much more complicated DOM manipulation and code, making the layouts more complex and harder to work with. This resulted in something known as spaghetti code, a term developers use in web development to describe code that is complex, convoluted, and difficult to understand, like spaghetti. React prevents this spaghetti code by avoiding any manipulation of the DOM. Instead, React provides something known as the virtual DOM. You may recall that this is an in-memory representation or clone of the real DOM, which minimizes updates to the DOM itself. React uses the virtual DOM to update the browser DOM only when needed. This ensures that the update is as minimal as possible, increasing the application's speed and performance. In this video, you learned about the basics of React by exploring the concepts of the component-based architecture, components, and the virtual DOM. Recall how you learned about functions in JavaScript? They are reusable blocks of code that can take an input, perform some procedure or calculation, and then return an output. Well, a React component acts much like a traditional JavaScript function. In this video, you'll continue your exploration of the structure of the React architecture by learning about functional components, component types, JSX, and transpiling. React provides 2 types of components: functional components and class components. They behave very similar in React to traditional functions and classes in JavaScript. Don't worry about class components for now. You'll learn more about them later. Instead, let's just focus on functional components, which act like a JavaScript function. In the default React application, only one component is rendered, and it's the app component located inside the index.js file that's located inside the source folder. It's important to know that every React app must contain at least one component, and it's called the root component. This component is loaded using the import statement. You'll learn more about the import statement in React later. For now, just know that it's used to import code needed for React to work, such as the import React and import React DOM statements. The syntax to render a component is very similar to a self-closing tag in HTML. You just place the component name inside the left and right angle brackets, and don't forget the /. The root component can contain other components that developers create to represent the various UI parts of the application, like in the e-commerce example that you learned about earlier. And recall that this component is ultimately converted to a DOM fragment and placed into the existing DOM as a child of the HTML div element with an ID of root. This div element is then rendered to the browser. If you analyze the app component, you'll notice that it looks very similar to a JavaScript function with some HTML code inside. You may also notice an export default statement. You'll learn more about this soon. For now, just know that you need it to make your components available. Okay, so now that you're familiar with the concept of functional components, let's explore how web developers create them in React. React is scripted using a special kind of syntax called JavaScript XML, or JSX. For many React developers, this is known as a syntax extension to JavaScript. So, what is JSX syntax like? Let's find out by going back to our React default app component. Recall that in the return statement of the app function, it seemed that some HTML content is returned. Well, this content is not exactly HTML, it's JSX. JSX syntax looks very similar to HTML, and one of its advantages is that it allows you to write JavaScript code inside what looks like HTML elements. In fact, you can think of JSX as a combination of custom HTML and JavaScript. This allows you to make your website dynamic. You'll learn more about the differences between HTML and JSX later. For now, just know that you can place this syntax inside the return statement of a functional component. It's also important to know that a React component won't render until it's used as a JSX element, just like a JavaScript function declaration won't run until it's called or invoked. Okay, so now you know what JSX is. Let's explore the steps involved to create a React component, which will contain some JSX code inside a heading 1 HTML element to display some text on a web page. First, you create the component, which is basically just a JavaScript file. Since its purpose is to return some heading text, you name the file heading.js. Notice that the first letter of the component name is capitalized. This is because there's a difference in how React treats capitalized and non-capitalized component names. So it's important to remember that all component names in React must be capitalized. Why is this? Well, because React treats lowercase components as regular HTML elements. Capitalizing a component name helps React to distinguish JSX elements from HTML elements. Now let's continue with our component. Next, inside the app.js file, create a function named heading. The function name must also be declared using a capital letter for the first letter of the function. Then, inside the function body, you create a variable named title and assign it the string value of "this is some heading text." Now you're ready to create the return statement of the function. Inside the parentheses of the return, insert a heading 1 tag and inside it, place the variable named title. To make React evaluate the title variable, you need to place it inside curly brackets. If you didn't use curly brackets, you'd get the word title instead of "this is some heading text." At this point, it's worth remembering that while you are creating HTML-like syntax, you are actually coding inside a JavaScript file. And because of this, you can output a variable inside your JSX code, something you cannot do when writing static HTML. The overall syntax instructs React to render the heading HTML element with whatever text value that is stored within the variable named title. This rendering happens behind the scenes because of something called transpiling. You can think of transpiling as a process of converting JSX to HTML, and you'll learn more about this later. In this video, you learned about functional components and how to create them in React. You also learned about JSX, which acts like a combination of HTML, CSS, and JavaScript that you can use to generate dynamic content inside your functional components. Finally, you explore the concepts of rendering and transpiling. If you would like to learn about these concepts in more detail, there's a link to an additional reading at the end of this lesson.
In this video, you will further explore the concepts of components in React and learn how to create a component from scratch. You'll be introduced to the concept of the export statement and how components can be used to create reusable blocks of code. I've launched VS Code here and I have the creating component folder open in the built-in terminal. Now I'll execute the command npm init react app dot. The dot character instructs VS Code to run this command in the current folder. In other words, I'm using create react app to build a new app for me inside this folder. I execute this command by pressing the enter key. I wait for the app to build, and once it's ready, I can start the app by typing npm, then a space, followed by start. The process of building the React app could take a couple minutes, so just sit tight while it builds. Great, my React app has started and loaded in the browser at localhost 3000, which is the local server. Notice that I have all these files and folders in the left pane of VS Code now, such as node modules, public, src, and files like package.json. You'll learn more about these later. For now, the only folder I need to work in is the src folder, so don't worry about all these other files and folders. Instead, I want you to focus on how to build a component in React, and to do that, let's have a clean start. The easiest way to do this is to remove all the code inside the function inside the app.js file. I guess you might say this is the simplest possible component. I'm declaring an app function and I'm exporting it as a default module. I save my file and notice that my app is just a blank page. Now let me create another component that'll contain some text that I want to display in the browser. To do this, I create another function called header, and in the function body, I'll just return some greeting text inside an h1 JSX element. Inside the h1, I type hello world. My code looks good now, but my screen is still white. This is because I'm not yet rendering anything from my app function. To do this, I need to return to my app function and call the header function from it. I use the JSX element syntax to render a component, which is the name of my function. So inside the body of the app function, I create the return statement and type the function name of header inside left and right angle brackets, not forgetting to add the / before the right angle bracket. Notice that the syntax to render a component is very similar to a self-closing tag in HTML. Press Ctrl S or Command S if you're on Mac to save everything again. Great, my code is working now, and I notice an HTML heading with the text Hello World displayed in the browser. Congratulations, in this video you learned how to create a functional component. This component named app calls another component named header, which displays an HTML heading with some text. At the moment, the header component code exists in the same file as the app component. To make the header component isolated and reusable, I need to place it in its own file. Then I can reuse it multiple times in the application anytime I want to display a heading element with some text. And you'll learn how to do this very soon. In this video, you learned how to create a functional component in React and render it to the root component named app.js.
As you might already be aware, it's important to organize or structure your React components so that they're easy to access. But what does a structure look like? What files and folders are found within a typical React application? The React project structure is the focus of this video. By the time you reach the end of this video, you'll have learned how to explain the default folder structure of a React project, outline the benefits of the folder structure, customize the folder structure to hold components and assets, and explain the benefits of planning folder use for app development. Let's begin by examining how the default files and folders are laid out in a React app project. When you build a React app using the command npm init react app, your project is comprised of a specific file and folder structure. Notice that there are 3 folders named Node Modules, Public, and SRC or Source. Let's explore each of these folders briefly now. First, let's begin with the Node Modules folder. You can think of this folder as a repository for all the modules in your React app. The Node Modules folder is automatically added when you install a specific npm package. You might recall that packages are groupings of files and/or node.js modules. Developers use packages when they want to add a piece of functionality that someone else coded and made available to other developers via the npm ecosystem. Don't worry too much about the Node Modules folder. For now, just be aware of it and that it's needed for your React app to work. Next is the public folder, and it contains the assets that will be displayed to the user in your app. For example, image files for logos, the favicon which displays an icon in the Browser tab, and the robots.txt file which is used for search engine optimization. Also, there is a manifest.json file which is used to provide some metadata to a device when your React-powered web app is installed on it. While all these files are necessary, the most important one to know about for now is index.html. A React app gets injected into the specific element inside the body of the index.html file. Based on changes happening inside a React app, it injects those updates in that same div of index.html. You'll find out more about how this works later on in the course. Finally, let's explore the contents of the SRC or source folder. This folder contains all the essential component files required to ensure that a React app functions. And notice that there are some files already in this folder. These were automatically created when I used the npm command create React app to build a starter React app. As a React developer, you'll probably spend most of your time within this folder, so let's get a little more familiar with some of these files now. You may be familiar with some of them already, such as index.js and app.js, which are used to render the root component of the app. Let's briefly explore the others. App.css contains the styles for the app.js component, and the index.css file contains the styles that are used in the entire app. App.test.js, setuptests.js, and the report web-vitals.js are files related to the app's performance and testing. The logo.svg file is displayed on the start page of the default app when the app is displayed in the browser on the local host. While these can be useful and their functionality is important, I can still safely delete them without affecting React's ability to create a very basic application. I just need to also remove the code that references them. This is because React doesn't have opinions on how you organize your files and folders in the source folder. However, there are a few common approaches popular in the ecosystem, and you'll learn about them soon. It's at this point it's also worth remembering that the most important file in the entire source folder is the index.js file. This file imports everything that this React app needs to render a working React app. Okay, so now you have explored the main folders. Let's explore the files in the root of the default app. Root files are additional files that are found in the root of the project folder itself and include a gitignore file, 2 JSON files, and a README file. The .gitignore file is used in version control, and it's used to specify what files and folders must be excluded from a project. It's important to know that this file is not specific to React. This means that other systems use this file too. The readme.md file is a markdown file that gives some basic information on this project. Developers use this when they want to share the project's code on a site like GitHub. The package.json file lists information pertaining to my app, which allows npm to run several scripts and perform various tasks in the app itself. Finally, the package.lock.json file holds the list of all dependencies with their specific versions. The package.json file helps npm rebuild the app on another machine, or if we delete the node modules folder with all the files that our project needs to run, the package.lock.json file has all the information for npm to be able to rebuild those files reliably. This file is there to ensure that npm tracks all the modules installations properly. As a general rule, it's better to leave these files where they are for the moment, as they are required for the app to function. You should now be able to explain the default folder structure of a React project and outline the benefits of the folder structure. In addition, you should know how to customize the folder structure to hold components and assets, and be able to explain the benefits of planning folder use for app development. Good job. One of the advantages of component-based architecture is that your app is split up into individual self-contained components. And as you have already learned, these components can be used to build powerful UIs based on reusable components of code. In order to create a fully functioning React app, you need to create a collection of components. But with the app broken into several different components, you might be wondering, how do you locate and integrate them all into your app? In this video, you'll learn about the concept of modules and how to manage your React components by placing them in a components folder. Finally, you'll explore the structure of the import and export statement. As a developer, you often need a way to use and reuse components that may have been defined elsewhere or created by someone else. For example, do you recall the concept of modules in JavaScript? Modules are standalone units of code that you can reuse again and again. Being standalone means that you can add them to your programs, remove them, and replace them with other modules, and everything will still work. Well, in React, you can make use of this JavaScript feature to separate your components by placing them in their own file. Then you can use the import and export statements to make the files communicate with each other. The export statement is used to make a module available to another module. It helps to think of every JavaScript file as a module. Then in order to make the functions and variables available to other files, you need to export them, which makes them available via the import statement. In JavaScript, there are two types of exports: default exports and named exports. The default export is used when the function name is the same as the file name, and named exports are used when you want the function name to be different from the file name. At this point, you may be wondering, what is the difference between modules and components, since they are both essentially just JavaScript files? And you're right. While they have similarities, it can help to think of a component as a single part or small piece of functionality, like a button. Then you can think of a module as something that's larger than just one component, like a series of components. This technique of splitting your code into several modules is known as modular programming, and it complements the component-based architecture of React. To help you understand this better, let's explore the following scenario. Suppose you're a developer currently in the process of building an application with React, and there are several components that need to be included in the app. Some of the required components have already been created by your fellow developers, so you need a way to import them into your app. To do this, you need to use the operation known as importing. And in React, you import components into your application using the import statement. You may have already noticed the import statement in the default index.js file, where the app component is rendered. In React, to import a component, you use the keyword import, followed by the component name you want to import. Then you use the keyword from to specify the location of where the component is located. You need to use a file name sequence such as a // before the file name, but the file name extension is not required. Okay, so now you know about the syntax of the import and export statement. Let's explore how you can structure your component in React. Remember that a component is essentially just a JavaScript file. React doesn't have strict rules on how you put files into folders. However, there are a few common approaches you may want to consider. One approach is to place all components in a folder named components. This allows you to structure your projects by grouping similar files together. For example, suppose you are building a payment page for an e-commerce app. The page contains 3 sections that will each be represented by a component in React. First, a header section using a component called header. Then, a payment section using a component called main. And finally, a sidebar using a component called sidebar. Each component will be called and have its contents returned to the root component of our application, which is app.js. In this video, you explored the concept of modules and the structure of the import and export statement. You also learned how to manage your React components by placing them in a components folder. By now, you should be familiar with the concept of functional components in React. They are reusable blocks of code that act much like a JavaScript function. Recall that in JavaScript, you can make your functions more flexible by declaring them with parameters that allow you to pass in values as arguments when you call the function. Well, in React, you can perform a similar action using something called properties, which are represented as props. In this video, you'll learn about the props object and how developers use it to pass data from one component to another. Then, you'll explore component hierarchy and learn why components are said to have a parent-child structure. Before you begin your journey with props, let's revisit another piece of JavaScript functionality that will help you understand how props work. It's called the JavaScript object. Recall that in JavaScript, an object is a special type of variable that can contain many values. You use objects when you need to store groups of related data of different types, and each data type is known as an object property. For example, suppose you create an object called fruit that contains properties for type, quantity, and color. Remember that these properties consist of name-value pairs, and you can access the object's properties using dot notation. In React, you can use a similar technique to pass data from one component to another using the properties object, or simply props. Props allow you to pass data from one component to another. It's helpful to think of props as arguments that components can accept and are passed using JSX syntax, much like HTML attributes. Inside a function, you use the keyword props. Okay, now that you're familiar with the concept of props, let's explore an example to send some props to a component and print them out in a React app. Suppose you have the default code for the React app open. In the index.js file, you call the app component. Inside the app component, you return an h1 heading with some static title text. While this code works, you can make this heading dynamic by using props. Let's now explore the syntax involved to create this. In the root component index.js, you send the value you want to pass to the app component as an argument in the form of an HTML attribute. Next, in the app component, you accept this argument using the props object. To do this, you add the keyword props to the function declaration inside of the parentheses. Finally, to access this object's properties, you use dot notation to reference the name of the object property that was passed as an argument by the HTML attribute. Once again, remember to enclose your code inside curly brackets so React knows that you want to work with a props object and not static text. Because props is essentially a JavaScript object, it can accept many data types ranging from simple types such as strings and integers to more complex types such as functions, arrays, and objects. As a result, props allow developers to have greater flexibility when creating and working with components, especially when you want the flow of data in your app to be dynamic. While you just explored a basic example to dynamically print a heading, you'll get a chance to practice with more complex data structures using props later. Okay, so now you're familiar with how props work by sending data between components. Let's explore this data flow in a little more detail. When two components communicate with each other, the component sending the props data is known as the parent, and the component receiving the props data is known as the child. And as you've just learned with the example earlier, this parent-child relationship allows parent components to pass data down to child components using props. It's also possible for parent components to send the same data to multiple child components. However, it's important to know that this communication is a one-directional data flow. It's not possible to communicate from the child component back to the parent component using props. Instead, developers use other approaches. Don't worry about that for now. You'll learn more about them later. Although props are a very powerful tool in React, they do have some limitations. For example, you just learned about how it's not possible to send data from the child component back to the parent component using props. Another important limitation has to do with something called pure functions. In programming, a pure function is a function that will always return the same output for the same argument values that are passed in. Don't worry too much about pure functions for now. Just keep in mind that in React, when you declare a component using props, it must never modify its own props. In this video, you learned about how props are used to pass data to components. You discovered that a prop is a special React object that works in a similar way to a JavaScript object, and that its properties can be accessed by dot notation. You also learned why developers use props in order to make their apps more dynamic and flexible. Finally, you examined some of the limitations about using props in that you cannot use them to send data back to a parent component, and that functions using props must never modify its own props. By now, you should be familiar with the concept of props, and that they allow you to pass data from one component to another. Developers use props when they want the flow of data in the app to be dynamic. This makes the app more versatile, helping it consume data easier. In this video, you'll learn the syntax involved to use props in components. You'll also explore the passing of props to and within a component using functions. During this course, you were introduced to an example of how to build a simple blog layout in React using components. Now you'll be introduced to a new component called the nav component. Developers commonly build navigation menus using HTML unordered lists. A navigation menu is basically just a list which can be styled easily with CSS. Such a snippet of code is well suited to be placed in its own React component, making use of the HTML nav element to act as the block of code to return the JSX from inside the function. For example, the return statement can contain several HTML-like elements, such as UL and LI tags. And this same nav component can also be rendered as a JSX element to which we can pass dynamic value with props. In order to do this successfully, you need to be comfortable with the concept of attributes. The best way to develop an understanding of attributes is with a live example of building a component using props. Here's a practical way to work with props. I'm in my app with the header, main, and sidebar components, and all of them are rendered from the app component. The app component is in this case referred to as the parent component, and the header, main, and sidebar components are referred to as the children of the app component. I'll now pass data from the app component to each of its children components. First, the header component receives a name prop with the value of Anna, and a color prop with the value of purple. I'm sending those props from the header JSX element inside the app component's return statement. Press Ctrl S or Command S on a Mac to save these changes. However, my recompiled app is not showing any changes because I send this data through the props object to the header component. I'm not using this data in the header component. So let me open the header component and I'll first pass in the props object. For now, I'll just console log the props object. Again, press Ctrl S or Command S to save the update and wait for it to compile. If I now inspect this object in the console, I find the console logged props object, and it comes with two properties, the name Anna and the color purple. I can now access the values of the two properties inside the header component using props.name and props.color. To make sure that the expressions are evaluated inside the JSX syntax, I must surround them with an opening and a closing curly brace. I press Ctrl S or Command S on the Mac again and wait for it to compile. Now my header shows the props data it received from the parent component. I'll now update the main and sidebar too. Back in the app component's render statement, I add the greet prop with the value of howdy in the main JSX element and the value of hi in the sidebar JSX element. I open the main components file and receive the props object, then output the value of opening curly brace, props.greet closing curly brace. I can now delete the hello string. Similarly, in the sidebar components file, I'll also receive the props object and replace the hello with an opening curly brace, props.greet closing curly brace. I click File, Save All, and wait for the app to compile. All my components are now using the data they received from their parent component, using their respective props objects. You should now be able to effectively demonstrate the passing of props to and within a component using classes and functions. Great work! At this point in the course, you've been introduced to the concept of JSX and how it's used to interact with components. In this video, you'll explore JSX in more detail in the context of component and styling. You'll also learn how to mix JavaScript, HTML, and CSS within a component. So, what is it that makes JSX so special? In one word, expressiveness. Developers can express what they want React to render using a very expressive syntax, almost identical to HTML or XML. In other words, JSX allows developers to write HTML directly inside JavaScript code. For example, you can add navigation function to a website by creating a nav component, then place the HTML semantic nav element and an unordered list inside. And because this is React, the list values can be made dynamic by passing values as props. It's important to know that a regular JavaScript function is used to define how React should render the component, wherever it's referenced using the nav JSX element. And this is what makes JSX so powerful, like the fact that you can insert specific JSX expressions such as variables and props. The reason why this is so great to work with is because anything that's placed inside the curly braces of your code is essentially regular JavaScript code. For example, you could calculate a series of simple expressions using the li or list item tag. This means that you can think of the curly braces as being special areas where you can write any kind of JavaScript code you like. And you can write the rest of the code inside the return statement. Okay, so now that you've learned a little more about JSX expressions, let's focus on some JSX rules inside the return statement of the function. The return statement can be thought of as the area of expressive syntax that allows you to write regular HTML code as you'd like to have it in your rendered app. But if you need to return HTML code over multiple lines, it must be placed inside parentheses. This allows developers to alternate between regular HTML tags and dynamic values represented as JSX expressions inside curly braces. It's also important to remember that the HTML code must be wrapped in a top-level element, such as a div tag. If you do not want to add extra div elements to the DOM, you can use something called a fragment instead. This is like an HTML open and close tag without the tag name. While you can think of the code inside the return statement as regular HTML, it's worth remembering you are in a JavaScript file. And as a result, there are some differences. For example, you cannot use the keyword class to work with CSS classes in your HTML elements. This is because class is a reserved keyword in JavaScript. You must use a slightly different keyword called class name instead. Also notice that class name is written in camel case, which depicts the separation of words by using a single capitalized letter. You can use class name to list any number of CSS classes to style a specific JSX element inside a component. This is just like how you use the class attributes in regular HTML, and it's only one of the many ways you can style React apps. You'll learn more about how to do this later. For now, just know that this is the closest to what you would do, like if you were working with HTML and CSS website layouts. There are some other differences, and you'll learn about them later. But in practical terms, you can consider the code to be pretty much just like regular HTML. In this lesson, you explored further the concept of JSX styling and how it's used in React. You have now furthered your understanding of how to use JSX to mix JavaScript, HTML, and CSS within a component. Great work!
Recall that there are 3 techniques to include CSS in HTML documents. The first is inline by utilizing the style attribute inside the HTML element. Next is internal by using the style element in the head section. And finally, external by linking to an external CSS file using the link element. In this video, you'll learn how to take CSS style rules from an external file named index.css and add it inside a component as an internal style. These style rules can then be referenced by your code inside the return statement of the component. Notice that the components are styled by the external style sheet index.css. For this video, I'll continue working on an app which consists of the components header, main, and sidebar. This time, the focus will be on using internal styling inside the sidebar component. To demonstrate this, I don't need to move all the code from the index.css file. Instead, I'll just focus on the styles related to the sidebar component. For example, I select the CSS code for a side and cut it by pressing Ctrl X or Command X on Mac. After saving, notice that this removes the styling from the sidebar component displayed in the browser. Now let's go to the sidebar.js file where I'll paste the code before the return statement. This will not affect my component because I'm pasting CSS code into a JavaScript file, so I need to make some changes to turn this CSS rule into a JavaScript object. To do this, I need to declare a site style as a const variable and then replace the semicolons in the code with commas. I also need to replace the hyphenated names with camel case. It's important to know that because CSS declarations like background are now an object property, I need to make their respective values a string by wrapping them inside double quotes. And I also need to repeat this for the other new style elements as well. Finally, inside the aside tag in the return statement of the component, I need to add a style attribute by typing style equals aside style as a JSX expression. I then choose Save All in the File menu to save my changes. Notice that the sidebar component appears in the browser as before I edited the index.css file. So that's an example of using inline CSS styling directly inside a component. In this video, you learned how to take CSS style rules from an external file named index.css and add it inside a component as an internal style.
Recall that JSX is a syntax extension to JavaScript that is used with React. It allows developers to write HTML as part of their component code, and is frequently used in React as it offers greater flexibility. In this video, you'll learn how JSX is used and how to use its key feature, embedded expressions. First, let's examine a JSX example that will output some text on a web page. The code consists of a paragraph HTML element containing the phrase "Hello World." It is assigned to the constant variable named result. Note that when this JSX code executes, the result variable will contain a React element that can then be inserted into the web page. This is one of the key features of JSX, building React elements from HTML code automatically. Let's explore another important feature of JSX, which is embedded expressions. Embedded expressions allow developers to insert the values of JavaScript variables into the HTML of the resulting React element. Embedded expressions can also embed the output of functions. Let's say you need to output the person's name in a specific format. To do this, you can first create a function named formatName that will return the first name and surname with a space character between them. In your JSX, you can then call this function inside the curly brackets. As with the previous example, the value that the function generates for the JavaScript variable will be output in HTML. Expressions can also be used for HTML attributes. This is useful if you need to insert the address of a person's profile picture. To do this, first you would store the profile picture address in a variable named URL. The image will be displayed using the img element, so you should embed the URL variable into the src attributes. Note that the double quotes are not needed for the attribute value, as JSX will automatically add these. This is just one example of how JSX is an efficient way of outputting HTML elements that contain JavaScript variable content, and you'll encounter more as you progress. In this video, you explored several JSX examples, including one that uses embedded expressions to insert the values of JavaScript variables into HTML within a React element.
I'm building an application using React, and I now need to add a new feature to the app that renders images. I can do this by embedding a JS expression in an attribute, specifically the src attribute of the HTML image tag. Over the next few minutes, I'll guide you through the process as I complete the steps, and by the end of this video, you'll be able to demonstrate how to embed a JS expression in an attribute, including adding additional styling and importing additional assets, and utilize additional assets within an app by importing components. Now I'm in the app.js file of a new project and start with an app component that returns the h1 header text "Hello World." I've previously copied the avatar profile image from the Coursera GitHub account, which is publicly available through the GitHub API. I've pasted the images into the root of the src folder and named it avatar.png. In order to use the image, I need to import it into the app component. I then add a new function in the app.js file named logo. The logo function is essentially a separate component, but to keep things clean for this example, I'll save the code in the app component instead of a separate file. The logo function accepts the props object, and inside of the logo function, I declare a user pick const and assign it a JSX element. This is an image element, and I'm passing the imported avatar PNG image as the value of the src attribute inside this image element. Finally, I'm returning the user pick const from the logo function. Back inside the app component, I'll now render the logo component by adding the logo element inside the app component's return statement. Let me now preview my app in the browser. Great, so it displays the header text along with the image. Keep in mind that if I were to continue building this app with more components, it would be best to extract the logo component to its own file and then import and render it as needed. And that's a demonstration on how you can embed a JSX expression in an attribute, in this case the src attribute of an HTML image tag.
Well done! You've reached the end of this module on React components. Module 1 gave you an overview of the basic structure and use of React.js. The purpose was to enable you to produce single-page applications with React. Let's take a tour of the lessons to determine how it did just that. First, you learned about how React is used in the real world from Meta software engineer Katie. Then, to lay the foundation for the hand-on labs, you had a quick summary of the fundamentals of HTML, CSS, and JavaScript. And then you learned how to set up a project in VS Code and how to work with JavaScript modules. The second lesson was all about React components and where they're stored within your applications. In this lesson, you were introduced to component-based architecture, a design philosophy for building software based on reusable components of code, like the React library. You learned about component types and component-style layouts that use the virtual DOM. And you learned how to create components that form the foundation of UI design. In this lesson, you also learned more about JSX, a special kind of syntax that acts like an extension of JavaScript. You learned how to transpile it. In other words, converts JSX to HTML, which helped you to understand how a component is built. And in the ungraded labs, you learned how to build a new component inside the app component and have it rendered on screen, as well as how to save a component to its own file and importing it into its parent component so that it can be rendered on screen. The third lesson was about component use and styling. You learned how to pass data from one component to another using properties, and your ability to do so was tested in the ungraded lab. And in the other ungraded lab, you learned how to render one component multiple times using different props. You also learned more about how to use JSX and its embedded expressions and how to style JSX elements in a way that is functional and looks good. As part of this lesson, you learned how to use and manipulate props and components, define components using function expressions and arrow functions, invoke functions inside of JSX expressions, use expressions as props, declare components that require props, and use expressions and embedded expressions in attributes. After completing this module, you are now able to explain the concept behind React and component architecture, create a component to serve a specific purpose, Create a component folder and demonstrate how to create and import files within that folder. Use and manipulate props and components to affect visual results. And describe how to use assets within an app to apply styling and functional components. That's a great start to your React journey. Well done on completing this module, and get ready for the next one. By now, you're probably familiar with events in JavaScript. Recall that events are the process by which JavaScript interacts with HTML and can occur when the user or the browser manipulates a page. They provide enhanced interactive experiences, such as responding to mouse clicks, movements, or keyboard commands. Because events usually rely on some sort of interaction, they need to wait and listen in the background for that interaction to occur before they can be triggered. Every HTML element contains a set of events that developers can access by using HTML attributes commonly referred to as event listeners. For example, it's a common feature of a website or app to have a button that, when clicked, causes something to happen. This action is an example of an event and is accomplished with either event listener methods or by defining specific JavaScript functions. Developers can use events to execute JavaScript code in response to an action based on user interactivity, like clicking a button. This process by which the HTML button communicates to the JavaScript event handler to execute some code in response to the event action is known as triggering. For example, you might want to listen for a click event on an Add to Cart button. Once you capture such an event, you might want to run some JavaScript code. In this example, add a circle with a number 1 in the shopping cart to indicate one item has been added. If the same event gets triggered or fired again, our event handling code then handles the event by updating the count in the circle next to the shopping cart icon. The circle then displays the number 2 to indicate that there are 2 items in the cart. Events are a powerful tool and make up part of the document object model. As an aspiring React developer, you'll need to know how to work with events as they are handled a bit differently. By the end of this video, you'll be able to identify the broad types of events available in React and describe some of the most commonly used ones. You'll also know how to explain the event handling process in React at a high level. In React code, events are handled using JSX event attributes, which are very similar to HTML event attributes that you may be familiar with. For example, the click handling attribute in HTML is the onClick attribute with all the letters lowercase. The equivalent click handling attribute in React's JSX is the camel-cased onClick attribute. Remember that camel case means that the first letter is lowercase and the separation of words is indicated with a capital letter rather than a space. There are many events supported in React which can be divided into several groups. Those groups include clipboard events, composition events, keyboard events, and many more. Each group usually holds multiple events. For example, supported mouse events include onClick, onContext menu, onDoubleClick, and several others. You'll also find that the clipboard group has the useful events onCopy, onCut, and onPaste. There are far too many events to cover here, but you can find a complete list in the additional reading. The large number of event types that are accessible in React may seem overwhelming at first, but note that it's actually the browser that comes with these features, as the various devices that we use to access the internet have given rise to many ways for users to interact with websites. This means these events are not specific to React, and it's probably not necessary to learn about all of these events. Also keep in mind that many of these events are related to specific use cases. For example, several of the mouse events are limited to the drag and drop API. In other words, At this point in your learning journey, your focus should be on understanding the overall event handling process and what capabilities events can open up to you. In this video, you learned about the types of events available in React and how they came to be. Next, you'll explore specific examples and build the skills to use events confidently for various situations.
I will now show you how to handle several events in React using components. As a start, I've added a new component to the src folder. I named it btn, and for now it's just an empty function with a default export. Let me simplify the app.js file's return statement. First, I'll delete the logo import statement and import the btn component instead, and then remove the contents of the return statement. Then finally, I'll add the btn.jsx element so that it can get rendered. Back in the btn component, I add a button in the return statement. The button reads, "Click me." Press Ctrl S or Command S on a Mac to save, and the button renders on the screen. Now I'd like to handle a click on this button, so I add the onClick synthetic event, then an equal sign, an opening curly brace, click handler with a capital H, and a closing curly brace. In the return statement, I distribute the code on several lines to increase readability. Now I'm setting up the click handling behavior. Whenever a user clicks on the button, that'll evaluate an expression named click handler. I now need to define this click handler, and I'll set it as a function expression, meaning I will use the const variable keyword and name it click handler. Then I'll assign an arrow function to it. That's it. I've just set up a click handler that receives the click event that's fired from this button and handles it by outputting the word clicked in the console. Again, I save my changes, and in the browser, I open the developer tools. Now I locate and activate the console tab in the developer tools. I'll also zoom in on the button. When I click the button, the word clicked appears in the console for every click event. Back inside the btn.js file in VS Code, I select all the code in the btn component, right-click on the selection, and click the copy command in the contextual menu that pops up. Next, I use the keyboard shortcut of holding down the Control key, and while it's pressed down, press and release the K button, then pressing and releasing the C button, and finally releasing the Control key. So, Control K C. That comments out all the highlighted code. Right under this commented code, I now press the Ctrl V keyboard shortcut to paste in the code that I have previously copied. I will now show you how to handle a different event. Let me replace the onClickJSX event handling attribute with another one, and thus handle a different event. For example, I can replace the onClick attribute with the onMouseOver attribute, and update my event handling function accordingly to read mouse over. I save my changes and wait for the app to recompile. This time, when I hover over the button, the words mouse over are showing in the console. In this video, you've learned how to work with event handling JSX attributes in React.
Every time you click or tap a button, scroll down a page, or cancel a boring notification, you're producing events in the browser. And as you learned earlier, in order for these events to have any effect, you need to use event handlers that will then execute an action. For example, suppose you use a button to open a menu. Clicking the button is the event. The event handler is onClick, and the action that follows the event is opening the menu. There are a few approaches to adding event handlers to your React code that have different advantages, so you'll become familiar with each of them. By the end of this video, you will be able to describe the syntax differences for using event handlers in HTML and React. You will also know how to explain HTML function call and React component inclusion, and discuss the advantage of the component level of control. Suppose you're a developer working on a React app and you need to create a button that will trigger an event when a user clicks on it. With that scenario in mind, let's examine some code that accomplishes this in plain HTML. You might open a tag called button with the ID JSBTN. You then assign the onClick event handling attribute and set it equal to the click handler function. Next, you can add clickMe as a button text and finish with a closing tag. The code has an ID HTML attribute with the value JSButton, along with the event handling attribute onClick. While the HTML code in the example seems pretty straightforward, it's recommended to use JavaScript for scenarios like these instead. Why is that? Well, you'll find out later. But for now, you should understand that the equivalent code in JavaScript consists of two primary steps. First, you should use JavaScript to plug into the specific HTML element on which you'd like to listen to for an event. In the previous example, the HTML element is JSButton, which signals that it's a target element for allowing JavaScript to take control of the HTML structure. Second, once you've gotten access to an HTML element with JavaScript, you can then use the built-in add event listener method on the document object to attach a specific event listener. When you apply this method to the previous example, HTML is removed from the equation, but the code, on the other hand, is a bit more complicated. Specifically, you need to first declare a constant called JSButton and assign the value from the DOM. Then you need to add the click listener event and the function to run the code. Going back to React, the biggest difference in syntax involves the use of the add event listener method. In React, the rule is to avoid manipulating the DOM directly as much as possible. You should set everything up declaratively, meaning that you describe updates to React and let it figure out the rest. This is best done using event attributes, and fortunately, one-to-one mapping between HTML event attributes and JSX event attributes means it's easier to learn. Event handling in React is overall quite similar to HTML, but note that there is no function invocation syntax in event handling attributes in React. In other words, while in plain JavaScript you would need to pass an invocation to an event handling function as a value to the onClick events, in React you should not invoke a function. Instead, you just pass a reference to the event handling function without invoking it. To illustrate that point, let's compare the syntax of an HTML click handler event and its React JSX equivalent. In HTML, you provide the event handling attribute starting with on, and you append the name of the event, all lowercase. After the equal sign, you use a pair of double quotes, and inside of the double quote delimiters, you invoke the function that will run. Contrary to HTML, in React, you provide the event handling attribute starting with on, and you append the name of the event with each word's first letter capitalized. After the equal sign, you use the JSX expression delimiters, that is, the opening and closing curly braces, and inside of the curly brace delimiters, you add the name of the function to be run. Make sure not to invoke it. Finally, one more feature only used in React is the passing of function declarations as props. For example, in an app component, let's say you'd like to render a child component named counter. You can pass some data from the app component to the counter component using a prop. In this case, let's use an on-click prop that passes in the data that you want the counter component to receive. And there you have it. So the next time you're clicking buttons on a web page, closing notifications, or simply browsing through, you'll understand that those events are supported by some form of event handling. In this video, you learned how to distinguish the syntax for event handling in HTML and JavaScript. In this video, I'm going to demonstrate how to toggle the value of a Boolean state variable using user-triggered events, and how to handle multiple events on a single JSX element. In the example that you'll explore next, the code consists of another example of a component than what you've been used to so far in the course. The aim is to demonstrate how all the event handling concepts work together with state, styling, and the use of ternary expressions. Let's say that you have a component that uses state to keep a Boolean value of dark mode on. Based on whether the value of this variable is true or false, your component will render an h1 heading with some text in it, either as a dark theme or as a light theme. Additionally, it's possible to switch the theme with a button click. Now let's continue with an in-depth demonstration of event handling. I'm going to demonstrate event handling with an example so that you can gain practical insight into the use of events to provide additional functionality to an app. I'm going to build a component and I'll name it Mode Toggler. So in the Explorer sidebar in VS Code, I right-click the source folder and click the New File command. I named the file Mode Toggler, and for now, it's an empty function declaration with a default export. I press Ctrl S or Command S on a Mac to save my updates. Back in the app component, I update its return statements to render this new Mode Toggler component. I also need to import it on line 1 of the app component and save the changes to app.js. I now return some JSX code from my Mode Toggler component and add a return statement. In this statement, a JSX expression wraps the ternary which checks if the value of dark mode on is true or false. If it's true, it will return whatever is stored in the dark mode value, and if it's false, it will return whatever is stored in the light mode value. However, I don't have the values I'm evaluating yet, so if I save this code now, it throws an error. Instead, I define these values by declaring 3 variables above the return statement. These are dark mode on, which holds a value of true, dark mode, which holds the text dark mode is on in an h1 header, and light mode, which holds the text light mode is on in an h1 header. I save my changes and I get the sentence dark mode is on in the browser. Let me explain what happened here. The dark mode on variable is set to true. Just to do a quick test, I can change the variable name of dark mode on in the ternary to the value of true. Since this value is true, the value that's stored in dark mode will be rendered. If I change the value of true to false, the value that's stored in light mode will be displayed. I have replaced the test word false with our const dark mode on, and now I'll save it and test it again. Now I get the light mode is on displayed on the screen. I add a button with the on-click events to handle this toggle of the value of the dark mode on variable from true to false. So under this ternary statement, I'll add a button with an on-click event handler. I'll also define the handle click function. I start my function by taking the value of dark mode on and change it to the opposite Boolean value using the exclamation mark. That is the not operator. I then assign this value as the new value of the dark mode on variable. To explain this a bit more, if the value of dark mode on was, for example, true, then the not dark mode on will be evaluated to not true. This not true will be assigned to the dark mode on variable, thus becoming false. I now add the rest of the code for the handle click function, which is an if statement. The logic states that if the dark mode on is set to true, then console log dark mode is on, otherwise console log light mode is on. I could have perhaps written this code a bit differently, but I wrote it in a way that makes it obvious what is happening here. This is always good practice for a developer of any skill level so that they and others can easily examine the code at a later stage. I save, and once my app recompiles, if I click the Click Me button, I get the appropriate string output in the console. This brings me to an interesting conclusion. Although the console log is updating, there are no changes to the actual heading 1 on the screen. Of course, I can update it manually by changing false to true, then saving the app and waiting for a re-render to confirm that my changes have indeed happened because the previous heading of light mode is on has now become the heading that reads dark mode is on. But as soon as I click the button, the console log changes. However, the heading in the web app doesn't reflect this change. Why is this the case? To understand this, you need to go deeper into data flow in React and observe how it moves between components. Fortunately, you'll be learning that soon. Great job! You should now be able to demonstrate how to toggle the value of a Boolean state variable using user-triggered events and how to handle multiple events on a single JSX element. In this video, you're going to learn about data flow in React.js. In this case, data flow is in one direction only. Immediately, a question springs to mind. Why is one-way flow in React important? Let me tell you. This type of data flow ensures that the data is moving from top to bottom through the component hierarchy. It also ensures that changes are transmitted through the system. You'll cover this in more detail later. For now, in this video, you will also learn how to showcase the use of stateless and stateful examples by focusing on data flow. Imagine that data is money, and that money is controlled by your employer. This money can be considered props. This money props is passed to you and becomes your money state. The money props always flow from your employer to you, never in the opposite direction. In React, data is passed down from a parent component to a child component via props. A child component can't mutate or change its props. It can only read them and re-render. This means that the data comes from the parent and is just consumed in the child component. However, if this was always the case, then all you'd have in a React app is separate pieces of the DOM, acting as component templates to be filled up with the data they receive. While this works great, there'd be almost no interactivity. You've learned about passing data to a child component using props. However, there's another way to work with data in React components, and that data is referred to as state. All the data in React can be divided into props data and state data. Props data is data outside the components that it receives and works with, but cannot mutate. State data is data inside the component that it controls and can mutate. It also helps to think of it like this. The props data belongs to the parent that renders the component. The state data belongs to the component itself. To demonstrate this, let's open up VS Code and work through an example. I've built a new app using create React app. I have two files created, app.js and child.js. The app.js file defines the app component using a class definition instead of a function. When it's created, it initializes its state with a current date. The render function then renders a component called child. The child component has a prop named message defined, and its value is set as the current dates from the component state converted to a string format, which includes the hours, minutes, and seconds of the date. In the child.js file, the component renders the message prop in an h1 element. Now when I run the app, The state of the app component flows its data down to the child component props, and the h1 element will display the current date and time. Well done! You have now learned how children and data flows in React.js, and you should also be able to showcase the use of stateless and stateful examples by focusing on data flow. By now, you've probably already learned about some important and useful core concepts in React. At this point, you're ready to learn how to add interactivity, maintain state within a React component, and explore hooks. In this video, you'll be introduced to what hooks are, how they can be used, and why they are useful. As you progress as a React developer, you'll likely soon use complex components with stateful logic. Keeping track of state across components can become quite a task, and this is where React hooks can help. One key benefit of hooks is that they solve the problem of unnecessary code reuse across components. Let's find out how they do that. Hooks are functions that were introduced in React version 16.8. They let you hook into React state and lifestyle features from components. Let's observe an example hook. Specifically, you'll examine an instance of the useState hook, as it's the most commonly used one. This hook is used to manage the state within a component and keep track of it, and it's built directly into React. To use it, the first thing you need to do is import the useState from React so that it's available for use. The next step is to declare a state variable within a component. You can provide any name to the state variable and the setState function. For this example, let's call the state variable showMenu and the setState function setShowMenu. If you've learned JavaScript, this syntax may feel somewhat familiar to you. You are probably wondering what exactly this code does. Well, it's actually doing something that you've likely encountered before. Notice that the convention is to name the state variable and the setter function using array destructuring. When you declare a state variable using the useState, it returns a pair which is an array with 2 items. Without array destructuring, the code would be long and cumbersome. Since it's more confusing and tedious to access the array items by index, array destructuring is preferred, and it significantly simplifies the code. You now have a new state variable called showMenu. The useState then sets the initial value of showMenu as false. So to summarize, calling the useState hook does 2 things. It creates a state variable with an initial value that represents the current state, which in this example is showMenu, and it creates a function to set that state's variable value, which in this case is setShowMenu. The function setShowMenu is used to update the value of showMenu by passing the Boolean value to it. It does not matter what names you use for the state variables. You can define them based on your component and use case. The useState hook should be called at the top level of your component. In this example, notice that the useState hook was used to track the Boolean state value. You can use the useState hook to track any type of data. It could be strings, numbers, arrays, booleans, or objects. For instance, you can even track the number of times a button was pressed. In addition to the hooks that come out of the box with React, you can also build your own hooks which will let you extract custom component logic into reusable functions. This is an excellent feature and benefit of using hooks. The biggest benefit of hooks is the readability and simplicity that they provide to the code. In this video, you learned the basics on React hooks and explored the useState hook. You now understand the benefits of using hooks and how you can use them within your React applications. Consider the different modes in an alarm clock and the situations you would use them in. Typically, you have alarm on for setting a time to wake up, alarm off for when this feature is not needed, and snooze for sneaking in a few extra minutes of sleep. Setting these modes doesn't require adding anything extra to your clock. They are built-in features that can be set with a push of a button. If you create this feature in a React app, you could create a component named clock and then pass in the status values via props. Recall that props is a feature of React that essentially allows you to hold information about the UI in the browser. In React, you also have another way to do this by using a similar concept called state, which also allows you to easily change how the component behaves in order to suit a given need. By the end of this video, you'll be able to describe what state is in React and why developers use it to control what is displayed in the browser from a component. It helps to think of state as a component's internal data that determines the current behavior of a component. And it's often used to store data that affects the behavior of a component. State is important because it allows components to stay in sync with each other and ensure that your app behaves as intended. For example, if one component updates its state, all other components that depend on that state will automatically update too. This means that a component sends its state to its children by using props. If the child components have their own grandchild components, then the child components might have some states that they send as props to those grandchild components. In React, state is kept in a state of variables. The main way to change state is to alter these variables. When a component is created, it gets an initial state. The state is used to initialize the component's properties. Components can be either stateful or stateless. But what exactly does that mean? To gain a better understanding, let's explore an example of each. First is an app component with no state defined. It performs a single action, which is to render the text a stateless component. And then you have a stateful function component. This component also renders some text, but it references a variable to do so. You'll explore how that works a little later. For now, notice the syntax used in the first line of the app's function body. If you're familiar with how array destructuring works in plain JavaScript, this line of code might already make sense to you. But to make things clear, consider an example array called fruits, which contains the three strings apple, pear, and plum. With its ES6 version, JavaScript introduced the concept of array destructuring, which allows you to assign several variables from the array using a single line of code. In other words, you can assign apple, pear, and plum to the fruit 1, fruit 2, and fruit 3 variables quickly instead of one at a time. With this in mind, let's come back to that line in the stateful component. Notice that the syntax used is similar to the array destructuring example you just examined, but with an interesting bit of code. React.useState. Hooks allow developers to hook into some otherwise inaccessible functionality. For example, to access the state object, you would use the useState hook. To better understand what is being destructured in the app component, let's call a console log to the useState hook. The output reveals an array holding two things, the string hello and a function. In this case, hello is the state value assigned to the word state variable. The function is a built-in one that is not declared. The function can be destructured with any name you'd like, but there is a convention to follow. If you set the state's variable name to be greet, then the destructured state function should be setGreet. This is because the second destructured variable is a function that will be used to update the state of the variable. So, let's examine an updated version of the stateful function component. Notice that the setGreet variable is not actually run. That is something that is done elsewhere. Later in this course, you'll learn about how you can extend this code with a clickable button to update the state. In this video, you learned about state in React, specifically the characteristics of stateful and stateless components in an app. Why do we use state in React? Because it's one way to deal with data in our React apps. State is a powerful tool in React that developers use to manage data that is likely to change in an application. Recall that the state data is internal to the component itself. This allows the component to re-render based on the changes in the state data and present the newest updates to the user. With that in mind, let's explore how you can update a component with the useState hook that you encountered earlier. The useState hook allows a component to define and track state. It does this with two arguments, the first of which accesses state, and the second of which updates it with a function. For example, you can use the date variable to access the date state, then use the setDate function to update the state. To help you understand how useful the useState hook can be, you're now going to explore an example that demonstrates how to use it to observe and manipulate the state of a component. Let's observe an app that was made for a Mediterranean restaurant called Little Lemon. It has a header child component which receives the props and the object. It also accesses the message property before it returns it and renders it as an H1 element. In the parent app.js component, I import the heading component and I set the word as a state variable, set to the string of eat. For now, I ignore the comment after the eat string. In the return statement, I wrap the heading component in a single div. I pass the message prop of word plus, and then in double quotes, at Little Lemon, all wrapped in an opening and closing curly brace. You already know that an opening and a closing curly brace signifies a JSX expression, which means that all the code inside of those curly braces will be evaluated as regular JavaScript. The JavaScript engine takes the word eat and concatenates it to the words at Little Lemon. Thus, in the browser window, I get the words eat at Little Lemon. If I want to update the value of the word state variable to something else like drink, I could use the setWord function directly to help me achieve this. However, when I save the change and run my code, the app does not work. This is because one can't use the state setting variable from your state directly. Instead of updating it directly, I can update it based on a click event. So I have another element called button, and onClick is equal to handleClick. I now set another function which I'll name handleClick. Inside the handleClick function definition, I run setWord to drink. I click File Save All and wait for the app to compile. Now when I click the Click Here button, I get drink at Little Lemon. To observe and update state, you can use the state setting functions and state variables using the state hook. But you must make sure that you use event handling attributes in JSX syntax or some other approaches, which you'll learn more about later. In this video, you have learned about state change basics in React, including how to apply the useState syntax to observe and manipulate state in components. Well done. In life, there are rarely perfect solutions that suit every need. For instance, this concept applies when it comes to selecting a vehicle. A small car is usually more fuel efficient but has limited space. On the other hand, an SUV can handle many passengers but burns fuel quickly. Making the best choice starts with identifying your specific needs. This is no different when it comes to choosing stateful or stateless component in programming. By the end of this video, you'll be able to describe the differences between types of state and choose the best type to suit a given need, and explain how the dynamic nature of React causes structure decisions to influence complexity. The distinction between stateful and stateless components is that a stateful component holds state as internal data, and its state changes based on the way that the app is built, often as a result of user actions. A stateless component, however, doesn't store state, and any changes must be inherited through props. When deciding if a component should be stateless or stateful, you can refer to the following rules. Use stateless components when your component doesn't need to maintain its own state in order to work. Use stateful components when your component does need to maintain its own state in order to work. This might sound like an oversimplification, but let's explore why this general rule is enough. A common approach for organizing components in React is to have a stateful component as the parent, which then sends its state down to several stateless components that then receive the state and render it on the screen. The children components are stateless because they don't have their own state and only receive their parent state when passed down by using props. Keep in mind that you should never change the values of props in children components, as they are immutable. Now that you know the basic logic, let's break down a specific example of this approach in action, starting with two components, the app component and the child component, which returns a message. In the app component, the useState hook defines and keeps the states that will be passed to the child component as the props object. The app component renders the child component and passes the date to it in a string format as a prop named message. One thing to keep in mind, and something that is often overlooked by React beginners, is that a prop doesn't always have to pass state. In addition to state, JavaScript values and functions can also be passed to the child component. It's still data, but it's props data rather than state data. In the child component, there is an h1 element. The content of this element will be the message prop that is passed into the component. Note that props are not changed or updated in the component as they are immutable, meaning they can't be changed. Since the child component doesn't store any state, it is a stateless component. All of its data comes from the props passed into the component. The app component stores the state which can be changed through events and functions and is therefore a stateful component. In this video, you learned why and when to utilize stateful or stateless components in your React apps based on your specific needs. You also observed that although a stateless component can't directly pass state, it can still trigger actions that will update the state of other components. During this course, you've probably learned a few approaches for managing state between a parent component and a child component. But have you wondered how well these approaches still apply for more complex apps with multiple levels of components? Fortunately, there are tools available to help you do just that. By the end of this video, you will understand how Context API can be used to manage state more efficiently across multiple levels of components. You'll also be able to perform basic state management using the useContext and user reducer hooks found in Context API. By this point, you're probably familiar with the practice of passing state from one component to another by using props. While passing props helps to manage state, it is like taking a bus and going through each stop before you get off at the end. In comparison, using the Context API is like teleporting to your destination instantly. It's a way to bypass the redundant passing of data through multiple levels of components. Remember that API stands for Application Programming Interface. An API provides a predefined set of ways you can interact with some code. The Context API thus provides a streamlined way to work with context in React. To set it up, you need to add a piece of code that will be your context provider and is also where the state will be stored. When a component needs to use the state, it becomes a context consumer. Now let's examine a simple app that utilizes the Context API to control state. In my app.js file, I'll use some code for a starter setup, and you can also find this file in the additional resources if you'd like to use it to practice working with Context API. In the app component, I have import statements for meals provider and meals list. The meals provider provides context state data and gives it to all the components it wraps inside the app component. Currently, it wraps two components, the meals list component and the counter component, which are between the div tags of the return statement. The meals provider component holds all the state, which is organized with the help of the Context API. First, I set the meals context variable using the react.createContext function. Next, I declare the today's meals array, which contains several food items saved as strings. I then code the meals provider as an ES6 function that accepts the children value. This value holds everything that will be wrapped into the meals provider component when it gets rendered inside the app component. The children value is just returned from the meals provider, wrapped into the meals context.provider JSX element. The meals context.provider JSX element comes with the value attribute, and this value attribute gets assigned the meals object, which is the value I set to the useState variable earlier. Before exporting the meals provider component at the bottom of the file, I'm also setting the useMealsListContext variable to the react.useContext call and passing it to the meals context as its single argument. This makes it easier for me to destructure the meals object from the useMealsListContext variable. Finally, in the meals list component, I'm accessing the context state by importing the useMealsListContext from the meals provider file. Let's break down how this component works in more detail. First, I'm destructuring the meals property from the object returned from the useMealsListContext call. The original object has a single property named meals, which holds an array of 3 meal strings. Once I destructure the meals property from that object, all I have left is the array of 3 strings saved in the meals variable, which allows me to map over the meals value, where I'm rendering an H2 for each member of the meals array. This code is probably more complex than most of what you have encountered. Don't worry if it takes time for you to understand how it works. Just remember the important parts, that this setup gives you a nice starting point for working with the Context API. And lastly, let's examine the counter component. Note that it gets the context data in the same way that the meals list component does. This is the usefulness of having a centralized state store. It allows me to simply reach into the state provider directly from whatever component needs it, without having to do prop drilling or lifting up state. Next, let me show you how the useReducer hook works. Let's move on to the useReducer hook. You can think of it as a super-powered useState. While the useState hook starts with an initial state, the useReducer also gets a reducer function in addition to the initial state. Let me illustrate that with a code example. Let's say I have a ride-share app that represents the amount of money in my wallet. The initial state is a value of 100, and the action of picking up a customer increases the value, while the action of refueling my vehicle decreases it. I've applied a reducer function, which takes in the state and the action. Instead of using setState like in the useState hook, I use the dispatch method of the useReducer hook, which accepts an object literal with a single property, type, set to a matching action.type, whose behavior is defined inside the reducer function. Now, when I interact with this app in the browser, I can increase the money value by clicking the A New Customer button, or decrease it by clicking the Refill the Tank button. In this video, you learned how the useContext and useReducer hooks can be used to manage state more efficiently across multiple levels of components. In life, there are rarely perfect solutions that suit every need. For instance, this concept applies when it comes to selecting a vehicle. A small car is usually more fuel efficient but has limited space. On the other hand, an SUV can handle many passengers but burns fuel quickly. Making the best choice starts with identifying your specific needs. This is no different when it comes to choosing stateful or stateless component in programming. By the end of this video, you'll be able to describe the differences between types of state and choose the best type to suit a given need, and explain how the dynamic nature of React causes structure decisions to influence complexity. The distinction between stateful and stateless components is that a stateful component holds state as internal data, and its state changes based on the way that the app is built, often as a result of user actions. A stateless component, however, doesn't store state, and any changes must be inherited through props. When deciding if a component should be stateless or stateful, you can refer to the following rules. Use stateless components when your component doesn't need to maintain its own state in order to work. Use stateful components when your component does need to maintain its own state in order to work. This might sound like an oversimplification, but let's explore why this general rule is enough. A common approach for organizing components in React is to have a stateful component as the parent, which then sends its state down to several stateless components that then receive the state and render it on the screen. The children components are stateless because they don't have their own state and only receive their parent state when passed down by using props. Keep in mind that you should never change the values of props in children components, as they are immutable. Now that you know the basic logic, let's break down a specific example of this approach in action, starting with two components, the app component and the child component, which returns a message. In the app component, the useState hook defines and keeps the states that will be passed to the child component as the props object. The app component renders the child component and passes the date to it in a string format as a prop named message. One thing to keep in mind, and something that is often overlooked by React beginners, is that a prop doesn't always have to pass state. In addition to state, JavaScript values and functions can also be passed to the child component. It's still data, but it's props data rather than state data. In the child component, there is an h1 element. The content of this element will be the message prop that is passed into the component. Note that props are not changed or updated in the component, as they are immutable, meaning they can't be changed. Since the child component doesn't store any state, it is a stateless component. All of its data comes from the props passed into the component. The app component stores the state which can be changed through events and functions, and is therefore a stateful component. In this video, you learned why and when to utilize stateful or stateless components in your React apps, based on your specific needs. You also observed that although a stateless component can't directly pass state, it can still trigger actions that will update the state of other components.
Hello and welcome. Imagine you want to cook a dish you never tried before. You can try different ingredients, different cooking times, or you can just use a recipe you found on the internet. In a similar way, as a developer, you can try to build your website from scratch, or you can use code that other developers created. In this video, I'll illustrate how to include CSS and JavaScript libraries in your HTML file. I'm also going to explain what dependencies are, the purpose of a package manager and JavaScript bundlers. Let's get started. By now, you know you write code in your application and that this code interacts with APIs provided by libraries and frameworks. Since you'll be deploying your application to a web server in the end, you must include these libraries and frameworks with it. If you do not include them, your application won't be able to call the API functions it needs to execute when you run it. That is why the libraries and frameworks are often referred to as dependencies. Your application depends on them. On the front end, you do this by referencing the JavaScript or CSS files in your HTML file. One popular library you can use to develop user interfaces is the Bootstrap library. You will learn more about Bootstrap in this course, but for now, let me demonstrate how a library such as Bootstrap can be included on a web page. Start by opening your HTML file. Next, add the CSS library for Bootstrap in the head element using a link tag. The link tag includes an href attribute to link the CSS library I am including. I also included a rel attribute to specify that the link is for a style sheet. Bootstrap also provides a JavaScript library that enables enhanced functionality such as drop-downs and tooltips. You'll likely need those features during development. So let me demonstrate how to add the JavaScript library to your web page. Open your previous file that already has the Bootstrap CSS. Next, add the JavaScript library for Bootstrap in the body element, using a script element. I then add an src attribute to the script element to specify the link to the library. Let me add a Bootstrap button to the page to demonstrate how easy it is. In the body, I add the button element. Then I add an attribute called type and the CSS class btn. I also add the modifier btn-primary and a description. Click this button. This will add a button using Bootstrap's primary color, blue, on the web page. This is what the rendered version of the code will look like. You can now start using the additional Bootstrap functionality. This is quite a simple example. In day-to-day development, however, it can end up being a lot more complicated. For example, what happens if your dependency also depends on other libraries and frameworks? This is known as a dependency tree. A project could have hundreds of dependencies in its tree. It will take a very long time to download, set up, and configure all of them. And how do you make sure you're using the same versions the rest of your team is using? This is where package managers come in. A package manager is a tool that automatically downloads and installs dependencies. We also refer to dependencies as packages. A package manager also provides the capability to publish your own packages, but let's not worry about that right now. For each dependency, you can specify a version of that dependency, and the package manager will download it for you. If there is a dependency tree, the package manager takes care of that for you. It will automatically download all of the dependency tree so that you can use APIs without dependency issues. The most common package manager for front-end development is the Node Package Manager, or NPM for short. You'll have an opportunity to explore the NPM later on. Now that all your dependencies are downloaded, you need to include them in your HTML file. But adding all of them into an HTML file will take forever. This is where you will use a bundling tool. The purpose of a bundler is to automatically combine them into a single file. If your bundle is significantly large, many bundlers can split your dependencies into multiple bundles. There are many bundlers available, such as Gulp and Webpack. You'll explore bundling in more depth later on. You now know how to include CSS and JavaScript libraries in your HTML file. You also know what a dependency is, what the purpose of a package manager is, and what JavaScript bundlers are. Have you ever wondered how the size of a website can so easily adjust between different devices like laptops and mobile phones? Well, the answer is responsive design. Responsive design means that a web page can automatically stretch or shrink depending on the screen it's displayed on. In the world of web development, you use responsive design every day. Let me share how it works. In this video, you will be able to explain how responsive design is used to provide the best user experience based on the device that the website is viewed on, describe CSS media queries and screen resolutions, classify fluid images, and differentiate between fixed and fluid grids. Phone, tablet, and computer screens, including the one you're probably using now, are made up of thousands of tiny lights called pixels. The resolution of your screen refers to the number of pixels it contains, most often expressed as the number of horizontal pixels multiplied by the number of vertical pixels. For example, a common computer screen resolution is 1920 pixels in width and 1080 pixels in height. Thanks to responsive design, websites can be correctly displayed on any of your devices. However, today we have many different screens with different resolutions, which is why responsive design is so important. And it is complicated by new high-resolution screens like the one found on your mobile phone. These screens group multiple physical pixels into one logical pixel to display smoother images and text. These are often used in your favorite smartphones to give more high-definition visuals, like making text, images, and rounded edges appear smoother and making the individual pixels less visible. Given all the possibilities and complicating factors, it would be challenging to develop websites that appear correctly on all kinds of devices if it wasn't for responsive design. Responsive design is a set of 3 practices that allows a website to automatically change its visuals. In other words, to respond based on the device it is displayed on. It is the combination of 3 techniques: flexible grids, fluid images, and media queries. Firstly, flexible grids are made up of columns, gutters, and margins. The space between the columns is called the gutter, and the spaces between the content and the left and right edges of the screen are called margins. Instead of defining website element sizes based on pixels, flexible grids are defined in percentage values, allowing them to adjust depending on screen size. Next, you have fluid images. By setting the CSS max width property of images to 100%, the images will scale down smaller if their containing column becomes narrower than the image's size, but never grow larger. This enables an image to scale down to fit in a flexibly sized column, rather than overflow it, but not grow larger and become pixelated if the column becomes wider than the image. Finally, there are media queries that are part of CSS. They allow developers to query the display size, orientation, and aspect ratio to conditionally apply CSS rules. For example, if you wanted your website background to appear blue on a screen size less than or equal to 700 pixels, like on a mobile phone, you could use a media rule to set the background depending on the size of the screen. Remember that I said responsive design is the combination of flexible grids, fluid images, and media queries. When these elements are used together, you build a website that will automatically adjust its layout based on the device, thus delivering a responsive grid. In responsive design, the pixel value specified is often referred to as the breakpoint. A breakpoint is the point at which a website's content and layout will adapt to provide the best possible user experience. A breakpoint can function in different ways across 3 different grids: a fixed grid, fluid or full width grids, and lastly, hybrid grids. Let's explore each of these now. Firstly, a fixed grid has fixed width columns and flexible margins. The fixed grid has a fixed content width that doesn't change in a specific breakpoint range, while the flexible margins occupy the remaining space on screen. Then, we have fluid or full width grids with fluid width columns and fixed gutters and side margins. The fluid grid has a flexible content width that goes edge to edge as per the screen size. In a fluid grid, columns either grow or shrink to adapt to the available space. And finally, there are hybrid grids that have both fluid width and fixed width components. Many responsive design frameworks provide multiple CSS rules based on different device sizes to provide the best visual experience. Now you know the importance of responsive design. In the next few videos, you are going to learn more about Bootstrap, the world's most popular framework for building responsive mobile-first sites. As a developer, you are tasked to design a website for the Little Lemon restaurant. One of the main requirements is that the website easily adapts to different devices, platforms, and screen sizes. Does this mean that you'll have to redesign the website for each device? No, relax. You do not have to redesign your website for each device. In this video, I'll introduce you to Bootstrap CSS class infixes and modifiers, and you will learn how you can use them to save you time. Let's get started. Bootstrap has quite a large CSS library, built by Bootstrap's developers using thousands of use cases. How it achieves this is through CSS classes and their variations through infixes and modifiers. It is important that you, as a developer, understand infixes and modifiers, and you will explore each of these terms. You will use class infixes for responsive breakpoints in the Bootstrap grid system. Let's go ahead and cover how infixes are used. You already know that breakpoints are the triggers in Bootstrap for how your layout changes across device or viewpoint sizes. Here are the responsive breakpoints available in Bootstrap and how we use them. Note that each has a specific name. Extra small is for screens less than 576 pixels wide. Small is for screens greater than or equal to 576 pixels wide. In Bootstrap CSS rules, this is abbreviated as SM. Medium is for screens greater than or equal to 768 pixels wide. In Bootstrap CSS rules, this is abbreviated as MD. Large is for screens greater than or equal to 992 pixels wide. In Bootstrap CSS rules, this is abbreviated as LG. Extra large is for screens greater than or equal to 1200 pixels wide. In Bootstrap CSS rules, this is abbreviated as XL. Extra large is for screens greater than or equal to 1400 pixels wide. In Bootstrap CSS rules, this is abbreviated as XXL. Did you notice that there is no class infix or dimension for extra small on the list? This is because extra small is the default breakpoint in Bootstrap CSS rules, as Bootstrap is mobile first. We use the abbreviations for these breakpoints as infixes in the CSS rules for the grid system. This basically means you have to insert the abbreviation into the CSS class name. I will show you how to use this shortly. Bootstrap components provide a pre-built set of reusable UI styles and elements for your web applications. Let's now learn how to use modifiers through an example that uses an alert element. I can have an HTML file where I set an alert primary CSS class that is applied to the element. Alert primary displays the alert using Bootstrap's primary color, which is blue. The -primary part of the class is the modifier. If you want to change this to red, for example, for an error message, you will use the danger modifier. Here is a list of modifiers available in Bootstrap: primary, secondary, success, info, warning, danger, light, dark. Alerts are often used to show information that needs immediate attention from users, such as warnings, errors, or confirmation messages. Bootstrap provides an easy way to create predefined alert messages, and it also has different types of alerts. The difference between the alerts is just the color used to display the predefined alert message. For example, the primary alert displays the alert using Bootstrap's primary color, which is blue. On the other hand, the danger alert displays the alert in red. Now, let's turn our attention to how this works in code. In this HTML file, I have a 6-column CSS class applied to a div element. In this example, I want to change this rule for large screens. To do this, I infix LG into the col CSS class by adding col-LG-6. Bootstrap components provide a pre-built set of reusable UI styles and elements for your web applications. For example, I can add an alert component. I do this by adding an alert CSS class, followed by the contextual class alert-primary. Now I have to identify the function of the alert. To do this, I add a role CSS class directly after the contextual class, alert-primary, and type alert. On the next line, I type the name that must be displayed on the alert, a message. Alerts are useful for displaying information, warnings, or error messages to users. The contextual class, alert-primary, will display the alert using Bootstrap's primary color, which is blue. The primary part of the class is the modifier. If I want to change the color to red, for example, for an error message, I will use the danger modifier. To change the color to red, I simply replace the modifier primary with danger. Now you have learned about CSS class infixes and modifiers and how you can use them to save you time. As you have previously learned, building a website using responsive design requires a responsive grid and responsive breakpoints. Bootstrap provides both of these as part of its library. The Bootstrap grid system helps us to create web page layouts through a series of rows and columns that house our content. For the grid, Bootstrap uses a 12-column grid system that can be fluid or fixed. The Bootstrap's grid system always has a container, rows, and columns. The container is the root element of your grid. Bootstrap's grid system always starts with the container. The container contains pads and aligns your content. Its width is determined based on the current responsive breakpoint. You can add rows, and inside each row, you can add columns. Let me demonstrate how we put this all together by using Little Lemon's website as an example. Alright, I have opened my joesburgerindex.html file. In this web page, I have added 2 columns to my row. Bootstrap is smart and will set the 2 columns to span 6 column spaces. If I want to control how many spaces a column uses, I can suffix a number. Let's shrink the price column to 4 spaces and expand the menu column to 8 spaces. To do this, I add the suffix -4 to the col CSS class above the prices heading. I also add the suffix -8 to the col CSS class above our menu heading. But here's the amazing part of Bootstrap. I can configure my content to use different layouts based on the device using the breakpoint-specific CSS rules. Let's have the content stack on top of each other on mobile devices and have them display side by side on desktop devices. Since columns will wrap to new rows, if we exceed the 12-column space, we can use this to stack content. For mobile devices, I'll set the columns to use 12 spaces, each by adding -12 as a suffix to the col rule for both columns. Then for desktop, I'll set them to 6 columns each by using a col-LG rule and adding the column sizes -6 as a suffix. I will save the file by pressing Ctrl and S or Command S on a Mac and open it on my web browser. Notice that now the columns are side by side. Next, I open my web developer tools by pressing the F12 key. In the top left corner, there is a mobile phone tablet button. Clicking on this button enables the device mode. This allows me to simulate different devices. I select to view my website on a mobile phone device. Amazing! My content has stacked vertically on mobile. Bootstrap has ensured our website will work on a mobile phone thanks to its CSS rules and grid system. This will save a lot of development time by not needing to develop different content layouts per device. Bootstrap's grid system is very powerful and suitable for most development needs.
Bootstrap includes a pre-made set of UI elements and styles to help you build your website. They range from alert messages to navigation menus. These are called Bootstrap components. In this video, you will learn how to use Bootstrap components. Little Lemon have added a new fried calamari dish to their menu, and they want to add it to their website. They also want to update their website to use Bootstrap components. First, let's add the new dish. To do this, in the menu column, I add a new H2 tag, and inside it, I add the name of the dish, fried calamari. Then I add a paragraph tag. Inside this tag, I list the ingredients. squid, buttermilk. Now I want to add an image of the fried calamari. So I use an image tag with its source attribute and the image file name calamari.jpg. And I add image-fluid class to ensure the image scales to its parent column's width. Bootstrap comes with a badge component that I can use to highlight that the dish is new. Let's add that now. Next to fried calamari, inside the H2 element, I add a span element and assign it a CSS class of badge. Now I can set the background color of my badge by adding another class, bg-primary. The contextual class bg-primary will display the badge using Bootstrap's primary color, which is blue. Inside the span, I add the text new. Next, I'm going to improve my visuals by using the card component for each dish. With card elements, I can style and accommodate different types of content like title, subtitle, body copy, and images. For the cards, let's have them stack on mobile devices and tile side by side on desktop. To do this, I add a row below the R menu H1 tag. I then add a div element for each dish of the 3 dishes. For each div, I apply the col-12 class for mobile devices and col-LG-6 class for desktop devices. Inside each div element, I add another div element that uses the card CSS class by adding one and copying and pasting it inside the other divs. I then move the code with the image tag of each dish to the card class. Instead of using img-fluid, I change each image to card-img-top. This will improve its visual style within the card. I then add another div for each dish and give it the card-body class. This will contain the text content of the card. I then move the header and paragraph of each dish into these card body elements. Again, to improve the visual style, I add a card-title CSS class to the header of each dish. In the paragraph element, I add a card-text CSS class for each description. This will contain the dish ingredients. Our menu has a much better layout now. Finally, let's update the prices. Under the price column, I add a table row or TR tag for the new dish. Then I add 2 TD tags. TD stands for table data, but from now on, I will just refer to it as TD. In the first row, I type fried calamari in the first TD tag, and in the second TD tag, I type the price $12. Then I add an alert to inform our customers about the new dish so they can try it out. To do this, I add a div element with the alert CSS class. I add the alert-info CSS class to change the alert to blue. Now I identify the function of the alert by adding a role attribute directly after the contextual class alert info and type alert. On the next line, I type the text that must be displayed on the alert. Try our new fried calamari. The website has a much better layout now. Hopefully Little Lemon will have a lot more orders now. There are many components available on Bootstrap. Maybe there are some more you can use to improve your website.
I'm sure you've noticed that when you shop online, websites will often provide you with personalized recommendations. But when your friends log into those same websites, the recommendations will differ. But did you ever wonder how websites adapt to different user profiles? In this video, you will learn the difference between static and dynamic content. You will also be able to differentiate between the role of a web server and an application server. By now, you know that when you open a website, a web server sends the website's content to your browser. The content can be static or dynamic. Static content is files that the server transfers just as they are stored on the web server, such as videos or images. Dynamic content, on the other hand, is generated when the HTTP request is made. For example, the content may be generated based on input from a user, or when you visit a news website, it would be based on the current date. What actually happens is that the web server communicates with another kind of server, called an application server or a backend. The application server generates the dynamic content that the web server sends back to the user's browser. Now you know the difference, let's look at examples of how websites update static and dynamic content. Say, for instance, you want to watch a video on a website. You click on the play button and a request is sent to the web server. The web server responds by sending the file to your browser. Now, how does this compare to dynamic content? Because dynamic content is generated while you use a website, it typically takes longer to generate than it takes to send back static content. For example, when you log into this course, the web server communicates with an application server to check that you are in fact enrolled. The application server confirms your enrollment and specifies what content should show for your profile specifically. Application servers perform more complex processing than web servers. For instance, they have to run the application logic, communicate with a database, and check permissions. To improve performance, different application servers have specific purposes. There are application servers for every type of content out there, from music streaming to creating your own blog. You can even create your own application servers, such as building a backend for a web application. But hang on, if dynamic content is slower to generate, isn't that a problem for big websites? Yes, it is. Application servers typically have a limited capacity on how many requests they can process per second. But fortunately, This is where the web server can help out. Web servers use a process called caching instead of generating content dynamically for every request. Caching means the web server keeps a copy of dynamic content. If the content is requested again, the web server can immediately send this cached version instead of passing the request again to the application server. On the first request for dynamic content, the web server checks if the content exists in the cache. If it does not exist, the content is requested from the application server and stored in the cache. The web server then sends back the dynamic content to the browser. On subsequent requests, the web server immediately sends back the content stored in the cache. This reduces the amount of dynamic content that the application server has to generate. Then, after a period of time or with the next user interaction, the web server updates the cache with the latest content. Now you know the difference between static and dynamic content, as well as the difference between web and application servers. With this new information, try to identify whether the content on the websites you visit is static or dynamic. Let's say that you're thinking of building a web app. You probably want a user-friendly, mobile-friendly experience. Then you should consider using single-page applications or SPAs to build a unique, speedy, and engaging experience for your users. You're probably using many SPAs every day. Think of your favorite social network or messaging app, or the map application you use to find local businesses. The great user experience you get is driven by single-page applications. So, what exactly is an SPA? How does it work? How is it different from a traditional website? Let's first explore how a traditional website works. Before the advent of modern JavaScript frameworks, most websites were implemented as multi-page applications. But this makes traditional applications resource-intensive to web servers, because sending entire web pages for every request consumes excessive bandwidth and uses CPU time to generate dynamic pages. If your website is complex, the site browsing experience may appear slow to users. It will be even slower if they have a poor or limited internet connection. To solve this problem, many web developers build their web applications as SPAs. It's called single page, but that doesn't mean your website has only one page of content. What it means is that there is only one HTML page that gets sent from the server to the browser. But that page will update its content as your users interact with your website. A SPA allows the user to interact with the website without the application needing to download entire new web pages. Instead, it rewrites the current web page as the user interacts with it. The result is a browsing experience that feels faster and more responsive to user input. When the user navigates to the web application in the browser, the web server returns the necessary resources to run the application. A SPA has two approaches to serving code and resources. The first is called bundling, and the second approach is known as lazy loading or code splitting. With bundling, when the browser requests the application, the server returns and loads all necessary HTML, CSS, and JavaScript immediately. With lazy loading, the browser requests the application, and the server returns only the minimum HTML, CSS, and JavaScript needed to load the application. Additional resources are downloaded as required. For example, when a user navigates a specific section of the application. Both approaches are valid. The choice depends on the size, complexity, and bandwidth requirements of the application. For instance, with the bundling approach, if your application is complex and has a lot of resources, your bundles will grow quite large and take a long time to download. You could end up with a site that is slower than a traditional web application. Let's explore an example. Imagine you have a site dedicated to reviewing movies. People never know what to watch next, so you decide to install a feature that randomly suggests the movie for a user. You create a web page that has a What to Watch Next button. You want to display a random movie name when the button is clicked. In a traditional website, when the button is clicked, the browser will send a post request to the web server. The web server returns a new web page containing the button and movie name. The web browser then renders the new page. In an SPA, when the button is clicked, the browser will send a POST request to the web server. The web server will return a JSON object. The application reads the object and updates by displaying the text of the movie name. That's more efficient because the rest of the page remains as it was, and its content does not need to be sent by the server and rendered by the browser. But what if you need to update the majority of the page to display a different form of content? Well, let's explore that scenario. Suppose you are building a web application that has 2 pages. One page shows the latest news, and the other page shows the current user's profile page. A navigation bar at the top of the site contains a link to each page. In a traditional website, when the user clicks the profile link, the web browser sends the request to the web server. The web server generates the entire HTML page and sends it back to the web browser. The web browser then renders a new web page. In a single-page application, different pages are broken into templates, also known as views. Each view will have HTML code that can be updated by the application. For instance, the profile page would have a username, a first name, and a last name. The web browser sends the request to the web server, and the web server sends back a file called a JavaScript Object Notation, or JSON object. This contains only the data to be displayed, such as a user's first name and last name, and the SPA will update the HTML. This is much smaller than sending an entire web page. The web browser then updates the web page by inserting the template with items replaced by the values in the JSON object. For your next website, consider whether its complexity suits a traditional multi-page application or would perform better as an SPA. Remember that a single-page application has 2 methods of delivering resources: delivering all resources immediately or delivering resources dynamically as required. If all resources are delivered when the application is loaded, the single-page application must include the views for every page on initial load. If resources are loaded dynamically, the single-page application requests the views as required and stores views in the browser for subsequent requests. Now you can compare some popular SPA websites to traditional ones and judge the performance difference for yourself. I'm sure you've created something from scratch before. I bet you realized how challenging it can be as opposed to using pre-made components. Think about the effort that goes into building a brand new house versus the convenience of constructing a modular building with pre-made components that you just need to put together. React is focused on working with components, which makes it simple to build functional user interfaces on web and mobile. And since React is one of the most popular JavaScript libraries, it's important that you can explain what its purpose is and describe how its components work together. Available since 2013, React is an open source library with a community of core contributors and companies that maintain it. Developers use React to develop single-page applications, and you can also develop mobile applications with React Native. When you develop an app, you can choose to use React to develop the user interface, but building an application requires more than that. You must also consider the navigation and how the app will request data from a web server. Therefore, React is used in conjunction with other JavaScript libraries during development. But what makes React so useful is that it allows developers to write less code to create functionality. This in turn makes it easier to maintain code in the long term and simplifies testing. Because it is so central to front-end development, there are many tools that you can use with React. These tools can help you understand how React is running your code and how you can improve performance. Now that you have a better idea of what React is, let me tell you more about React's components. The key concept behind React is that it allows you to define components that you can combine to build a web application. A component is basically a small piece of user interface, such as a music player or photo gallery. This component model allows you to do several things, such as developing and testing parts of their application in isolation, and it also allows you to reuse components across multiple sections of the application as well. Let's explore an example. Most web applications have user profiles with pictures. Normally, several parts of the application use a version of this profile picture, such as in the navigation bar beside the user's name. It could also show in a user search result along with several other user pictures. And the user picture might also display in instant message notifications. Instead of programming the logic for every instance of a user profile picture, React allows you to create a user icon component that displays a version of a profile picture every time it is used. You can then reuse this component throughout the application. Can you imagine how it will improve your efficiency? There are, in fact, many open source libraries that provide pre-made components for React projects. For example, if you want to add a video player to your website, there's a React component library for that. Or maybe you want to embed a map. There's a React component library for that too. As the React community grows bigger, it continues to add new features and improvements continuously. Annual React conferences encourage community sharing and introduce upcoming developments in the library. I hope that in the near future, you might be joining the React community as an active member. And as a future React community member, you now know the React library's purpose and how its components work together to make life easier for front-end developers. After all, why build something from scratch if the components are already there to use? By now you've learned that you can build components in React to develop user interfaces. But how do React components turn into the elements on the web page that you see? Remember, when your web browser receives an HTML page, it constructs a document object model, or a DOM, to represent it. But updating the DOM is considered expensive because it is very time-intensive for the web browser to do so. Every time the browser DOM is updated, it causes the browser to recompute the page. Yet many big and popular websites still load in no time today. How can it be? In this video, I will explain how React solves the problem by computing its own virtual DOM. Let's start with how React components relate to the website displayed in your browser. A React component has a one-to-one relationship to an HTML element that is displayed on the web page. But how does React keep track of which HTML elements need to be updated? This is where React's virtual DOM comes into play. When React builds out its tree of components, it builds out its own DOM in memory called the virtual DOM. The virtual DOM is a representation of the browser DOM that is kept in memory. React uses this virtual DOM to update the browser DOM only when it needs to. This ensures that your application is fast and responsive to user input. Let me explain how it works. React checks to see if the HTML components in the virtual DOM matches the browser DOM. If a change is required, the browser DOM is updated. If nothing has changed, then no update is performed. This process is called reconciliation. Let's break down what happens when you update a component in React. Firstly, the virtual DOM is updated. Then React compares the virtual DOM to the previous version of the virtual DOM and determines which elements have changed. The changed elements and only those elements are updated in the browser DOM. Changes on the browser DOM cause the displayed web page to change. In this video, you've learned that React constructs and updates a virtual DOM so that the browser will only update certain HTML elements instead of recreating the entire page. Planning an application as a series of components can be tricky at first, but after doing it a few times, it will become easier. You've already learned about the core internet technologies, and now you know that JavaScript libraries in React allow you to develop user interfaces much faster. Isn't it cool that you can develop user interfaces so quickly? In this video, you will learn how the component hierarchy works in React. Every React application contains at least one component, the root component or app component. Components are added to the app component to build out a tree structure of components that make up the application. Let's explore an example of how an application might be structured as components. Suppose your application is a shopping list of items that need to be picked up from the grocery store. At the root, we have the app component. The app component has two child components. new item bar, and shopping list. The new item bar component allows us to add new items to the list. The shopping list component contains a shopping item child component for each item in the shopping list. Even though the item itself might be different, such as chicken or noodles, it is displayed in the same manner as other items. Therefore, you can reuse the shopping item component to display multiple items. When a user ticks off the items, the list will update and remove the corresponding shopping item child component from the shopping list component. Now that you understand the component hierarchy, let's explore how a website can be broken down into components. As an example, I will talk you through a typical blog website. Normally, there is a heading, a menu, and a search bar. You also usually have a featured blog post that displays larger than previous blog posts below it. Now, let's unpack the component hierarchy. At the root of the component hierarchy, you have the app component. This is the entire web page. The app component has two child components, the navbar component for the navigation bar and the page component. The navbar component contains the title of the blog, navigation links for the website, along with a search component. In the page component, we have three components, the main feature component and two instances of a small feature component. The main feature component displays a blog summary about a specific blog post. In the small feature component, there is a blog summary and a thumbnail component to display an image associated with the blog post. Notice that the small feature component is used twice. It is the same piece of code, but for the second small feature, the code uses different properties. And that is exactly the benefit of building a website with React components. You can reuse code for multiple sections. Using a series of components to build an application can be tricky at first, but after you do it a few times, you will appreciate how handy it is. Good luck with planning your component hierarchies in React. You've reached the end of this module on UI frameworks. It's now time to review what you've learned during these lessons. Over the course of this module, you've explored the concepts of UI frameworks and libraries and covered an introduction to React. Let's recap the key points you learned and the skills you gained. You began the module with an introduction to UI frameworks. Following the completion of this first lesson, you should now be able to utilize CSS and JavaScript libraries, demonstrate a high-level understanding of dependencies, package managers, and JavaScript bundlers, and explain the key techniques and concepts of responsive web design, such as screen resolutions and fixed and fluid grids. You should also be able to develop a simple bootstrap website with the use of HTML and CSS. Utilize Bootstrap CSS library, including deploying class infixes for responsive breakpoints and class modifiers to change your CSS code, and demonstrate an understanding of Bootstrap's grid system by building a web page using the Bootstrap grid. Following your exploration of UI frameworks and libraries, you then covered an introduction to React and the JavaScript library for building user interfaces. Now that you've completed an introduction to React, you should be able to differentiate between static and dynamic web page content, list examples of how each type works in the context of web servers, explain what a single page application is, how it works, and how it differs from traditional web applications. You should also be able to outline the purpose of React as a JavaScript library, explain the concept of the React component model, and identify examples of common components. Demonstrate a high-level understanding of React components. Explain how React components operate as a hierarchy in order to generate a web page through the virtual DOM. You're now familiar with the basics of UI frameworks and libraries, and the basics of React and React Native. Excellent! You've made great progress. In this course, you were introduced to the foundations of web development. Let's do a brief recap of what you covered. Module 1 was Get Started with Web Development. In this first module, you learned about the different types of web developers and the roles and responsibilities of front-end, back-end, and full-stack developers. You gained knowledge about the core technologies of HTML, CSS, and JavaScript, and explored the concept of how the internet works. The module also featured an example to show what a day in the life of a web developer is like. Next, you learned more about web pages, web servers, and web browsers, and how they all work together to create what we call the internet. You covered what happens when you send a request to look for something online and how that information gets back to you. Then, you were introduced to core internet technologies and how they interact. You explored some web browser tools that you can use to help you code more efficiently. Finally, you learned what an IDE is and how it can help you speed up your work to write code. An introduction to HTML and CSS followed in Module 2. In Module 2, you learned about HTML and CSS. In HTML, you discovered how to create an HTML document, use simple HTML tags, and link documents to create a website. Then, you learned about the Document Object Model, or DOM, and how it's used to display the content that you see on your device. In addition, you covered techniques to improve web accessibility and some assistive technologies available to provide universal access to the internet. Next, you learned how to use CSS to style web pages. You explored how to select and style elements and use text, color, and alignment to make the web pages you create look great and offer a great user experience. You then used your new HTML and CSS skills together to create a web page. In Module 3, you learned how to use the Bootstrap framework to build responsive interfaces and got to know the benefits of working with UI frameworks. First, you were introduced to the concept of responsive design and working with libraries. Then, you learned how to get started with the Bootstrap library and how to use Bootstrap styles, and you explored some alternative UI frameworks and libraries. Finally, you were introduced to the JavaScript library React. You learned why it was created by meta engineers and how it works at a high level. You then briefly explored the virtual DOM, component hierarchy, and some alternatives to React. Well done on completing this course recap. Now it's time to put into practice all that you've learned in the graded assessment. Are you ready to edit your biographical web page? Good luck. Congratulations on completing the Introduction to Web Development course. You've worked hard to get here and developed a lot of new skills during the course. You should now have a great foundation of front-end web development skills that you can build on. And you've also demonstrated your skill set by editing and styling a web page in the graded assessment. Following completion of the first course, you are now able to describe the web developer job role, distinguish between front-end, back-end, and full-stack developers, explain how data moves through the internet, and describe the technologies that underpin the internet. The key skills measured in the lab showed your ability to use HTML to create a simple web page, use CSS to define the style of a simple web page, outline the concepts that exist in most UI frameworks using Bootstrap as an example to directly reference common practice, and use the Bootstrap CSS framework to create web pages. In addition, you should now have the ability to use Bootstrap documentation to reproduce and modify CSS components, use Bootstrap themes to speed up your workflow, and describe the basics of React in relation to other frameworks and web technologies. So, what are the next steps? Well, this is the first course in the Meta Front-End Developer Professional Certificate. While you've established a good foundation so far, there's still more for you to learn. So if you've enjoyed this course and want to discover more, why not enroll in the second course? Throughout each of these courses, you'll continue to develop your skill set. And in the final assessment, you'll bring together all the skills you've learned and create your own fully functional website. Whether you're just starting out as a technical professional or student, This project will prove your knowledge of the values and capabilities of React. You'll have a functional website to include in your portfolio to demonstrate your skills to potential employers. This shows employers that you are self-driven and innovative. It also speaks volumes about you as an individual and your drive to continue your growth. Once you've completed all the courses in this professional certificate, you'll receive a Coursera certification for Meta Front-End Developer. Meta certifications provide globally recognized and industry-endorsed evidence of mastering technical skills. Congratulations once again on reaching the end of this course. It's been a pleasure to embark on this voyage of discovery with you. Best of luck, and do continue to follow your learning journey.